Okay, today we are starting chapter 4 with which is dealing with matrices. Okay, so chapter 4.1 is organizing data with matrices. Okay, that's the plural form. Singular is matrix. So our objectives today are to identify the specific elements of a matrix. So we're looking for the elements, determine the dimensions of a matrix, use multiple representations of data arrays, and we're going to create a matrix representation for the vertices of a geometric figure. Okay, so lots of new stuff going on. Matrices are probably something you've not ever used before, but they're going to be very helpful. Like we've just been working on solving systems and like getting into the systems with 3 equations and 3 variables. Matrices can actually make your life a lot easier than doing all the work with the systems. Okay, so matrices are used to quickly solve systems of equations. They help graphic artists and computer programmers edit, render, and manipulate images, which is pretty cool. They use them a lot. And matrices are the mathematics behind a lot of amazing animations. So if you think of Pixel, of Disney, like so many things are animated, video games, okay, matrices are the mathematics behind those animations. Now, do I understand the math, like how that computes, how the math computes to the animation? Unfortunately, I do not, but I do know that it's there and necessary for those animations. So pretty cool stuff. All right, first of all, then let's look at a matrix. It's a rectangular array of numbers. Okay, so this over here, right here, this is called a matrix. So notice it's a rectangular array. Okay, it's just a rectangular setup of numbers. Each number is called an element or an entry. So 2 is an element. 4 is an element. 6 is an element of this matrix. Okay, each number is an element. They are named with a capital letter. So this one is matrix M. Doesn't matter. It can be matrix O. It could be matrix C. It could be matrix L. Okay, but it has to be a capital letter. They're always arranged in rows. Okay, remember the rows are horizontal. Okay, so a row is horizontal. So 3, 7, and 5. Maybe I shouldn't have crossed that out, actually. Let's erase this. Okay, so in this one we have 2 rows. The first row has 2, 4, 6. The next row has 3, 7, 5. So they're arranged in rows and in columns, which are the vertical. So the column 1 is 2, 3. Column 2 is 4, 7. And column 3 has a 6 and a 5. This is why it's called a 2 by 3 matrix. It has 2 rows. So the first number is the number of rows. The third number is the number of columns. Okay, so that's how we name them. It is always enclosed in brackets. Okay, again, I've covered up the brackets there, so hopefully you got those notes down. All right, so it's always enclosed in brackets. And the dimensions are given in the form m times n. Okay, that's that 2 by 3 over here, where m is the number of rows and n is the number of columns. Why it's m and n and not like RC, I don't know. But if you want to write there that it's R times C to help you remember it's the rows times the column, that is fine with me. The other thing is it's often notated this way. Okay, so M is the name of the matrix, and then we use subscripts to write it's a 2 by 3. Okay, so that's what it's saying. M is the name of the matrix, 2 times 3 is the size. So for the ones down below, we'll state the dimensions and maybe we'll practice naming those as well. Okay, all right, so let me clear this and we'll keep going. All right, so in example 1, we want to state the dimensions of each matrix. Okay, so actually let me move this back down a little bit to where we've got some information about the matrix. All right, so the dimensions. Remember, a matrix is named in the number of rows, by the number of columns. Okay, is how we name the matrix. So, or state its dimensions, not how we name it, but how we state its dimensions. So, A, well, B already did for you, I guess. I don't really know why. That was goofy of me. Anyway, so A has, let's look at the number of rows. It has a row with 3, 4, and the row with 1, 6. So it has 2 rows by how many columns? Well, it has a column here and a column here. So this is a 2 by 2. Its dimensions are a 2 by 2, which is why, if you notice, it's also called a square, pardon me, a square matrix, okay, because it has the same number of rows and columns. It makes a square. So if we named this, okay, we would name it A, and then we would use a subscript 2 by 2. B, for some reason, I already gave you the answer. It doesn't have a, it's not a square matrix, okay, but it has 4 rows, 1, 2, 3, 4. Maybe I should put arrows on those. I'm not good looking arrows. 4 rows and 3 columns. 1, 2, 3. So it's a 4 by 3 matrix. So if we were naming it or notating it, it would be B, because that's the name of the matrix, and it's a 4 by 3. Okay, C. What is C? What are its dimensions? Good. It has 1 row by how many columns? Perfect. It's a 1 by 4. This is called a row matrix because everything is just in a single row. So if we name this, it's going to be C, 1 by 4. And D. So how many rows does D have? Good. It has 3. 1, 2, 3. And how many columns does it have? Just 1, which is why it's called a column matrix, because it has 1 column. So how would we name it? Excellent. It'd be D, 3, 1. Okay, perfect. So stating the dimensions of the matrix and naming them, super easy. Got to get all the new introductory stuff down. All right, subscripts are used to identify elements in a matrix. Okay, so we can identify elements in a matrix using a subscript. So the element in row 2, okay, so let's think about that. Row 2, so row 1, row 2, row 3, okay, and column 3. So columns, we have column 1, column 2, column 3. So the element, remember, an element is each number. So the element in row 2 and column 3. So row 2, column 3. Okay, we would say, we express that as A, 2, 3. So the name of this matrix is A, and this is the second row, third column. So let's apply that in example 2. It says state the value of each element in the given matrix. So notice this is matrix B, and we want to know what is element B, 1, 1. So again, this is row 1, 2, 3, 4, and column 1, 2, 3, 4. So we have a square matrix here, and we want element 1, 1. So row 1, so this row, column 1. That's this number right here, 3. It's kind of like a multiplication chart. Okay, what's element B, 2, 3? So again, B is just the name of the matrix, although when we're looking at it as an element, it's a lowercase. And we want 2, 3. So the second column, so in this row, or the second row, pardon me, the third column, this one. So that equals 14. Okay, so the next element, B4, 4. What is B4, 4? Excellent, that should be 8, right? 4 and 4 is 8. And the last one, what's B3, 1? Perfect, it should be 12, because it's in the third row and column 1. The third row and the first column. Perfect! That's very nice. So just picking out the different parts of your matrix. All right, then on to the back. Example 3 says translate the data into matrices. Oh, hold on, I missed the first part. Go me. So data from graphs, charts, tables, spreadsheets, the coordinate grid, any of it can be put into a matrix form so that calculations and manipulations can be done to them. All right, because it's like an algorithm we put into the computer. And so if we have them in a matrix, we can manipulate them a lot easier. So in example 3, we want to translate the data into matrices. Then we're going to state the values listed and what each element represents. So the elements, the values of each element that are listed. Okay, so example A is a bar graph. Okay, it's kind of a little hard maybe to see there. But we've got this bar graph of Katie's music practice, and we want to translate it into a matrix. So first of all, we need to name the matrix. You could name it K for Katie, M for music, P for practice. We don't care what you name it, right? Like it does not matter. So I'm going to name it P for practice though. So P equals. And we've got to look at the things that are going on here. Okay, so we're calculating the hours that Katie practices. Okay, but if we look here, we see that we're calculating it by the number of the weeks, right? The first week, second week, third week, fourth week in these 2 months, January and February. So it's like, well, how do we put this into a matrix? Okay, each of these things mean something. So in this first one, in week 1, okay, in January, she practices 5 hours. In February, she practices 6 hours. So those are our numbers, 5 and 6. So we don't need the hours. Like those are our elements. Okay. I guess what I'm trying to get at is, okay, we need to figure out like how we're transferring this data to the matrix. Okay, because we have rows and we have columns. So what do our rows and columns represent? And so the rows and columns aren't going to represent the hours. That's going to be the elements. The rows and columns are going to have to represent the weeks and the months. Okay, so if we think about just like this, we have 4 bar graphs or 4 bars, sets of bars. So we're going to have 4 rows. Okay, so our rows are going to represent the weeks. So we're going to have a row for week 1, week 2, week 3, and week 4. And that means then that our sorry, I said rows. I keep saying rows. These are our weeks. Our columns are the weeks. Our rows are going to represent January and February. So in week 1, okay, of January, she practiced 5 hours. In February, week 1, she practiced 6 hours. Okay, then week 2, in January, she practiced, what do we have, 8 hours, and in February, 7 hours. So in week 2, she practiced 8 hours in January, 7 hours in February. All right, in week 3, in January of week 3, how many hours did she practice? 3. So we're going to put a 3 in that spot. In week 3 for February, she practiced how many hours? 9. So we're going to put a 9 in that spot. Okay, week 4, how many hours did she practice in January? 2. And how many hours did she practice in February? 4. So there is our matrix. Okay, we've got it right there. So if I was going to name this matrix, it would be P. And what are the dimensions of this matrix? Good, it's a 2 by 4. Okay, because we have 2 rows and 4 columns. Excellent. Okay, then I need to slide down here. I'm going to keep my matrix. Slide down here to answer some of these questions. I might have to erase some of this stuff. However, Not for sure. Okay, so this information, right, you don't have to write the weeks in the January and February. That just helps you make sense of it. I probably should have left it to answer these questions, but we'll make it. All right, so it wants to know element 1, 2. What is element P 1, 2? So remember, we're in matrix P, row 1, so in this row, column 2. So that's 8. And what does 8 represent? What does 8 represent? Well, that's the hours Katie practiced when? In the second week of what month? Excellent, January. Okay, that's the number of hours Katie practiced the second week of January. Sweet. All right, let's look at the next element. What's the element P 2, 3? So in the second row, the third column. All right, good. That's a 9. And what does that represent? Good. It's the number of hours, or just hours, however you want to do it. Number of hours Katie practiced when? In the third week. Good. The third week of what month? Excellent, of February. Perfect. So the number of hours that Katie practiced during the third week of February. Awesome. Very fantastic. All right, let's look at B. How are we going to put this chart, okay, this spreadsheet, into a matrix? Okay, so we've got summer camp, scripture, memory, challenge. We've got our team points. We've got the blue team, the red team, the green team. Okay, so really it's super simple to just transfer this information into a matrix. You just have to put it in matrix form. That's it. So let's call this S for scripture, right? We'll call it S for scripture. So my numbers are 12. I'm going to finish my bracket. 5, 8, and 16. I needed to know how long to make my bracket. So my first row, or my first column, is 12, 5, 8, and 16. Then I'm going to have 10, 11, 10, 10. Oh, sorry, that's not a 10, is it? That's a 19. It's so hard to read on the board up here. I'm sorry, so 10, 11, 10, 19. That's why I check them. And my last column is 15, 4, 3, and 13, and 12. Okay, notice it is important to line these up to make them like this is a row, this is a column, make them nice and lined up well. All right, so what are the dimensions of this matrix S? What are the dimensions? Good, it's a 4 by 3. Okay, so this is a 4 by 3 matrix. That's going to come in handy in the next lesson, knowing that stuff. So it's a 4 by 3 matrix. Is it a square matrix? No, it's not, right? It's not a special one. It's not a square, it's not a row, and it's not a column matrix. So nothing special about it. All right, let's slide up the element questions and answer those. Okay, what is element S24? S24. So it's in the second row. I do have S24, right? We don't have one. What on earth? We don't have one, right? Oh, that was my plan. I forgot. Love when that happens. I confuse myself. So element S24, we would say there is not one or not applicable. Sometimes that happens. So I put that in there on purpose and then I confuse myself or forgot about it. All right, so how about element S43? So it's in the fourth row, the third column. Perfect. That is 12. Okay. And what does that number represent? Okay, you might have to go back and look at your spreadsheet if you don't remember. 12 is what? The points earned by the green team when? Okay, on day 4. Good. So 12 is the number of points earned by the green team on day 4. Okay, and so that's, again, like if we look here, we see that 12 is the points earned by the green team, so it's team points, by the green team on day 4. Okay, so we're just finding up where those things match. Okay, then let's do this last one, C. So now we're taking a coordinate grid, the points on a coordinate grid, and we're putting them into a matrix. Okay, so we're calling this matrix W because it makes a W, right? When it's graphed, the points make a W. All right, so how many points do we have? All right, we have 5 points on there, 5 coordinates that we're looking at. Okay, so, and how many, like, how would we name point A? Great, this would be -2, 2. Okay, so we have 5 points, and each of those has 2 numbers to it. It has an X and a Y. So when we set up our matrix, we can have 5 columns. We'll have a column for A, B, C, D, E, so for each point, and we'll have 2 rows. We'll have a row for X and a row for Y. Okay, so A, we're going to have is -2, 2. B, what's the point for B? Good, -1, -2. So for B, our next column, we're going to have -1, -2. C here is 0, 0. So in our matrix, we're going to have 0, 0. D is good, +1, -2. So in our matrix, we're going to have +1, -2. And E, what's the ordered pair for E? +2, +2. Fantastic. So in our matrix, we're going to have +2, +2. All right, so let's look at what those elements represent, or what those elements are. So what is element W15? So it's in the first row and the 5th column. Okay, so it's this one, right? So element 15 is 2. And what does that represent? Okay, that's the X value of which point? Of point E. Okay, good. How about element W23? So it's in the 2nd row in the 3rd column. So right here. So that element W23 is 0. And what does it represent? Good, that one's the Y value of point C. Perfect. Okay, so matrices can be really, really awesome. And we're going to work on just getting them set up to get us started. All right, see you guys tomorrow.